Dear students, I welcoming you in the third lecture of subject Basic Transportation Engineering. We covered the first topic road payment in first and second lecture. Today we see the second topic stability of road payment and soil stabilization. The subtopics factors affecting stability of payment, necessity of soil stabilization, procedure or principle of soil stabilization, types or methods of soil stabilization. Stability of road pavement is the resistance against permanent deformation when load is acting. Stability of soil subgrade is improved by soil stabilization. Soil stabilization is a process to improve soil stability or to improve soil bearing capacity using controlled compaction, proportioning, and admixtures additions. Factors affecting stability of pavement. First factor is vehicle and traffic factors. That means vehicle types, volume, and characteristics of traffic. Second factor is moisture factors. That is change in moisture content of subgrade due to precipitation, capillarity, and irrigation. Precipitations એટલે બાષ્પીભવન, કેપિલારિટી એટલે કેશાકર્ષણ અને ઇરિગેશન એટલે સિંચાઈ. થર્ડ ફેક્ટર ઇઝ ક્લાઇમેટ ફેક્ટર્સ. that is frost action by low temperature એટલે કે હિમવર્ષાને લીધે થતી અસર. Fourth factor is soil factors, that is types of soils and bearing capacity of soils. Fifth factor is stress distribution factors, that is pavement layers performance in transmitting load, vehicle load to the subgrade. These factors affecting stability of pavement. Second, necessity of soil stabilization. First necessity is to increase the compressive strength and shear strength of soil. Second necessity is to increase flexibility of soil to resist the load without deformation or without cracking. Third necessity of soil stabilization is to decrease the porosity of soil. Fourth necessity is to reduce swelling and shrinkage of soil. In swelling, the soil moves. In shrinkage, it reduces its volume. Third subtopic, procedure and principles of soil stabilization. First principle or first step is find soil properties in soil testing laboratory like plasticity index, plastic limit, elastic limit, etc. Second step is decide the method to improve the property by effective and economical method of soil stabilization. Third step is design the stabilized soil mix for targeted stability and durability value. Fourth step is perform the construction of soil subgrade by compacting the stabilized layers. So, in this manner or in this way, soil stabilization is carried out. Now we see the methods of soil stabilization. First is sand stabilization, also known as mechanical stabilization. Second is cement stabilization. Third is lime or lime plus fly ash stabilization. Fourth is bitumen stabilization. Fifth is chemical stabilization. And sixth is electrical stabilization. This is the major methods of soil stabilization used to improve the bearing capacity or strength of soil subgrade. Sand stabilization. It is used for clay soil. Sand reduces the cohesiveness of clay. The first step of sand stabilization is the soil subgrade is prepared in case of filling and excavated in case of cutting, maintaining design grade and camber. Step 2. Two parts of sand and one part of soil are thoroughly mixed. Step 3. Spread the mixture over the road alignment in 100 mm thickness, maintaining the desired grade and camber. Fourth step is sprinkle water less than optimum moisture content and compact up to 75 mm thickness using rollers. Here we use water less than OMC because sand is added in the soil subgrade and major part is sand. So we have to take water less than OMC. Step 5. Repeat the step 3 and step 4 to get desired thickness and check the design grade and camber. Field tests are conducted to check pulverization of soil, quality of water, moisture content and density of soil layer. Pulverization means making particle size in fine sizes. In this slide, the watering is done on the soil subgrade is shown, the rollers are shown, and the compacting work is running. Now cement stabilization. It is used for clay and sandy soil. As the cement hydrates, the mixture becomes hard and durable. Majorly, cement stabilization is used for cement concrete roads or airport pavements. First step, the soil subgrade is prepared in case of filling and excavated in case of cutting, maintaining design grade and camber. Step 2, add cement for clay soil about 14% and for sandy soil about 5% and mixed in dry form. Then spray water more than optimum moisture content and remixed. Here we used water more than OMC because cement required some water. So this additional water we have to use in mixing of cement and soil. Step 3. Spread the mixture over the road alignment in desired thickness and compact using rollers, maintaining the design grade and camber. Step 5. Sprinkle water up to 7 days for curing of cement. Field tests are conducted to check soil pulverization, quality of water, moisture content, cement content, and density of soil layer. Third method, lime or lime plus fly ash stabilization. This method is used for clay soil. Lime binds the clay particles and fly ash improves the lime performance. First step, the soil subgrade is prepared in case of filling and excavated in case of cutting, maintaining design grade and camber. Second step, pulverize the soil in small pieces. Add 5 to 10 percentage hydrated lime and 10 to 20 percentage fly ash in dry form. Allow to age for 1 day. Spray water more than optimum moisture content and remixed. Step 3. Spread the mixture over the road alignment in desired thickness and compact using rollers, maintaining the design grade and camber. Step 4. Sprinkle water up to 7 days. Field tests are conducted for pulverization of soil, quality of water, moisture content, lime and fly ash content, and density of soil. Fourth method is bitumen stabilization. This method is used for sandy soils. Bitumen binds the soil particles. This method is also used for clay soil if liquid limit of soil is less than 40% and plastic limit is less than 20%. First step, the soil subgrade is prepared in case of filling and excavated in case of cutting, maintaining designed grade and camber. Step 2, water is added as per optimum moisture content into soil and mixed. Step 3, heated bitumen is added into moist soil and remixed. For non-cohesive soil, add bitumen 4 to 10% by weight, and for cohesive soil, add bitumen 4 to 7% by weight. Step 4. The mix is spread and compact using roller up to design grade and camber. Step 5. The layer is allowed to age up to a time in which moisture and volatiles in the solvent evaporates. The bitumen is used by adding some solvents so it can used in liquid form. Field tests are conducted to check pulverization of soil, bitumen content, water quality and soil layer density. Fifth method is chemical stabilization. This method is used for both clay and sandy soils. Chemicals retains moisture so binds the soil particles. Calcium chloride increases maximum dry density of soil and sodium chloride creates a hard soil layer by crystallization in the voids of soil. Other chemicals are also used, but mainly these two chemicals are used. First step, the soil subgrade is prepared in case of filling and excavated in case of cutting, maintaining design grade and camber. Step 2, water is added as per OMC into soil and mixed. Step 3, chemicals are sprayed on soil and remixed. Calcium chloride is taken 0.5% by weight and sodium chloride is taken 1% by weight. The mixture is sprayed and compact using roller up to desired grade and camber. Field tests are conducted to check pulverization of soil, chemical content, water quality and soil layer density. And the last method is electrical stabilization. This method is used for cohesive clay soils. To decrease the soil volume, water is separated out from clay using DC current. First step is the soil subgrade is prepared in case of filling and excavated in case of cutting, maintaining design grade and camber. Step 2, drill the soil and penetrate metallic perforated pipe up to depth of 2 meter. Perforated means the pipe has holes in its surface, on its surface. Step 3, drill the soil and penetrate steel rods around the metallic perforated pipe at 2 meter radius. Step 4, pass the direct current or DC current in between pipe and rod. Due to current, flow of water becomes from rod to the pipe. Step 5, this water is pumped out from the pipe, so the volume of soil is decreased and strength of soil is increased. Field tests are conducted to check water content and soil layer density. To explain this electrical stabilization, we see the figure. Here, ground level is shown. Here, metallic perforated pipe up to depth 2 meter is penetrated into the ground. In top view, we can see the hollow pipe. A steel rod is penetrated and many steel rods are shown in top view around the pipe at equal radius. Now the metallic perforated pipe and steel rod are connected and direct current is given. So water table goes down and water is flowing from steel rod to the perforated pipe. In this way, so the water flow direction is from surrounding steel rod to metallic perforated pipe in center, and the water collected in perforated pipe is pumped out. In this way, electrical stabilization is performed. Today we studied the second subtopic, stability of soil and soil stabilizations. Thank you.